Okay, so artificial intelligence, it's pretty much everywhere now, isn't it?
Oh, absolutely. It's in your phone, maybe helping drive your car, even writing emails for you.
Right, exactly. It's so woven into, the fabric of our reality. And it makes you stop and ask a pretty big question.
Which is?
Does AI actually have limits? I mean, real hard limits. And if it does, what are they?
That's the million-dollar question, really. And technologists have been wrestling with it for decades. I think the first thing we have to say in this deep dive is a bit of a warning from history.
Okay.
Don't bet against AI. Seriously, every single time the experts have stood up and confidently said AI will never be able to do X.
Yeah.
A few years later, boom, exponential progress just blows that prediction out of the water.
That pattern,
Yeah,
the broken prediction pattern, that feels like the core thing we need to keep in mind today.
definitely.
So, okay, our mission today is to cut through all the hype, all the noise,
Yeah.
and give you a clear map of where AI is right now.
How are we going to do that?
We're going to look at the limits AI has already smashed through. Then we'll dive deep into the really hard problems, the current frontiers they're working on.
And finally,
Define what the roles really are for AI, and crucially, for us humans going forward.
sounds like a plan. So to really get this, we probably need some context on how AI actually works or learns. The DIKW pyramid is a good framework here.
DIKW, data, information, knowledge, wisdom.
Right, exactly. It's like climbing a ladder. AI isn't just, swallowing data whole. At the bottom, you've got data, just raw facts, unstructured.
Like if I just give you the numbers 10, 6, 42, 8, that's data.
Precisely, means nothing on its own, just stored somewhere, maybe a database, a digital pile.
Yeah.
Then you add information. That's where context comes in. So telling you those numbers or the ages of people in a room, suddenly it has meaning, structure.
That sounds like what traditional IT applications do, right? Processing facts into reports.
Pretty much, but the leap, the real AI leap, happens at the knowledge stage. This is about interpretation.
Okay, how so?
An AI looks at those ages 10, 6, 42, 8, synthesizes the information and makes an observation. It might say, hey, most people in this room are under 21.
So it's spotting patterns, deriving meaning from the context.
Exactly. And that's where today's sophisticated AI really shines, interpretation.
Which leaves the top of the pyramid, wisdom.
Yes. And wisdom is about applying that knowledge. It's often tied very closely to human judgment.
So using the knowledge that most people are under 21?
To make a decision, like deciding, okay, let's pick some age-appropriate games for this group. That step, connecting facts to intention, to maybe even ethics, that's the highest climb.
And that's a major focus when we talk about the current limits of AI. Yeah.
Absolutely. It looms large.
Okay, got it.
Yeah.
So let's unpack some of those historical milestones then, the things people swore a machine could never ever do. First up, reasoning and complex problem solving.
Yeah, this was considered the absolute peak. Human territory. People thought true reasoning, strategic depth, foresight,
Yeah.
that required consciousness, biology.
Intuition, maybe.
Yeah, intuition, exactly. But then 1997 happened.
Deep Blue,
Yeah.
IBM, against Garry Kasparov, the world chess champion.
So Deep Blue won. Look, we need to understand, this wasn't just about faster calculations.
No.
No. It fundamentally challenged the idea that things like intuition, planning ahead, complex foresight, the very skills Kasparov was famous for, were exclusively human.
It showed machines could reason, plan moves ahead. Lots of moves ahead.
Right. It basically redefined what machine intelligence could even mean. Huge moment.
Okay, so reasoning falls. What was the next impossible barrier?
Well, arguably something even trickier, natural language processing. You know, understanding human language, NLP.
Because language is messy, right? We use idioms, sarcasm, context.
Figurative speech, humor. If I say it's raining cats and dogs, a computer was supposed to just be confused. Too literal. That was the thinking for a long time.
I remember those early chatbots, like Eliza back in the 60s. Very simple pattern matching. No real understanding there.
Right, primitive. The paradigm shift, the really big one, came in 2011. IBM again, actually, with Watson.
Winning on Jeopardy.
Yes, and Jeopardy is such a perfect test case. It's not just about knowing facts.
Now it's full of puns, wordplay, cryptic clues.
Exactly. Watson couldn't just look up answers. It had to understand the double meanings, the jokes, the hints hidden in the phrasing to figure out the question. That needs deep inference. You can't just program rules for that.
And today's generative AI, wow, they've taken that even further. It's not just understanding idioms we feed them.
No, it feels like they anticipate what you mean, what you're trying to achieve. The simulation of understanding is so good, it often feels like genuine comprehension.
Which leads us right into the third barrier that got smashed. Creativity.
Ah, yes, the soul argument. A computer can't create anything truly new. It needs human experience, a soul. That was the common refrain for decades.
But now we've got AI creating art, writing music, even screenplays that win awards.
And the argument that, oh, it's just mashing up things it's seen before, well, it kind of misses the point, doesn't it?
Well, so.
I mean, look at human artists, composers, painters. They're always influenced by what came before them. Their work is a variation, a synthesis.
So AI doing the same thing, synthesizing something new and, aesthetically interesting from its influences, that is creation.
I'd argue it definitely constitutes creation, yes. A different kind, maybe, but creation nonetheless.
Okay, reasoning, language, creativity. What was the fourth big one?
Real-time perception and interacting with messy, unpredictable physical environments.
Robots navigating the real world.
Exactly. Think science fiction stuff. Machines making split-second decisions when everything is chaotic and uncertain.
The self-driving car has to be the prime example here.
Absolutely.
Yeah.
It's a robot operating in an incredibly complex, dynamic space. It has to instantly see everything around it.
Track cars, pedestrians, figure out what they might do next.
And make constant, high-stakes calculations and decisions in microseconds. That ability to integrate all that messy, changing sensory input and act immediately, that was thought to be purely biological territory.
Okay, so AI can reason, talk, create, and perceive in real time. Quite a list.
It is. But, as you said, the mission isn't accomplished yet. Not by a long shot. We still have some really significant frontiers where we're actively pushing the boundaries.
And a lot of these circle back to that top of the pyramid, right? To wisdom.
They often do. Let's start with emotional intelligence, or EQ.
Okay. Modern chatbots can seem pretty empathetic sometimes. They can, adjust their tone based on how you're writing.
They can definitely simulate understanding moods, yes. They've learned the statistically likely right response to human emotional cues. But the debate is that genuine awareness?
Or just a really, really good simulation.
Yeah.
Without any actual internal feeling.
Exactly. That line is still incredibly blurry and very much debated.
Then there's the big technical headache we hear so much about. Hallucinations.
Yes. This is a really tough byproduct of how current generative AI works. It's when the system just confidently states something that isn't true.
And it's not just slightly wrong. It can be spectacularly confidently wrong, making things up entirely.
Inventing sources, contradicting basic facts, it's a fundamental challenge rooted in their predictive nature. But the good news is there's a lot of work going into fixing this. Mitigation strategies are key.
Things like RAG, Retrieval Augmented Generation.
That's a big one, yes. Instead of just relying on its massive, sometimes flawed training data memory.
Which is where the made-up stuff comes from.
Right. RAG forces the model to first look up relevant information from a separate, trusted, up-to-date knowledge source, like forcing it to check its facts before it speaks.
Sort of like giving it footnotes or citations.
Essentially, yes. It grounds the AI's answers in verifiable reality, drastically reduces hallucinations.
Makes sense. We also hear about things like mixture of experts, MoE, and chaining models. Are those related?
They are. They're more advanced strategies for reliability. MoE, mixture of experts, uses lots of smaller, specialized models.
Like one model is good at code, another at history, another at medical info.
Exactly. And a routing system directs your query to the right expert model. So no single model has to know everything, which limits the potential for going wildly off topic or making things up.
And chaining.
Chaining breaks down a complex task into a sequence of smaller steps. The output from Model 1 feeds into Model 2, which feeds into Model 3, and so on.
Like an assembly line for thought.
Kind of. It allows for checks and balances at each stage, improving the overall logic and coherence of the final output.
Okay. These improvements are crucial, but they lead us towards the really big ambition, don't they? Artificial General Intelligence, AGI.
The Holy Grail, yeah. Current AI systems are amazing specialists, brilliant at specific things.
But AGI,
yeah,
that's different.
Yeah.
That's a single system as smart as a person across all the different areas, right?
Yes. Capable of complex reasoning and real-time perception and general knowledge and learning new things on the fly, like tying its own shoes, all in one system.
We're not there yet.
We are definitely not there yet. That integrated general-purpose intelligence is still elusive. And beyond AGI, you hear talk of ASI, artificial superintelligence.
Smarter than humans in every way.
That's still firmly in the realm of science fiction. for now.
Okay, another limit people bring up constantly is sustainability. You hear about the massive data centers, the electricity use, the cooling, the sheer cost. Is that a real fundamental barrier?
It's framed as a genuine limit to the current way we're scaling AI. We can't just keep throwing exponentially more processors and energy at bigger and bigger models indefinitely. It's just not sustainable.
So it's not just about making chips more efficient.
Efficiency helps, but the demand for bigger models is currently growing even faster. The real solution, the focus now, is on being smarter. It's about using the right size model for the job.
So not always defaulting to the biggest, most power-hungry model.
Exactly. Often, smaller, more specialized models can do a specific task just as well, or even better. Sometimes they hallucinate less and use vastly less energy. That strategic shift towards optimization is crucial for AI to become truly ubiquitous.
Makes sense. Let's loop back to the top of that DIKW pyramid again. The big challenge. Wisdom and subjective judgment.
Right. AI really struggles here, making ethical calls right versus wrong, making subjective judgments about quality that depend on human values.
Like predicting if a song will be a hit or judging abstract art.
Precisely. These things require a frame of reference grounded in human culture, ethics, and experience. And related to this is common sense.
Which is hard to program because
common sense isn't always that common, even among people. We all have different backgrounds, different assumptions. How do you encode that ambiguity?
very tricky. And that leaves one final barrier, perhaps the most profound one. Deep emotions and sensation.
Can an AI truly feel joy or sadness, loss, accomplishment? We talked about simulating emotion.
But this is about the internal experience,
Yeah.
the feeling itself.
Exactly. And beyond philosophy, just technically, integrating all the human senses, taste, touch, smell, into one cohesive, functioning AI system, that's still a massive engineering and scientific puzzle.
We can simulate sensory input, give it data about smells or textures.
But the gap between processing data about sensation and actually experiencing sensation consciously, that might be the final frontier. It's where computer science meets deep philosophy.
Okay, so AI can reason, plan, create, perceive. It's tackling hallucinations, pushing towards generality.
Yeah.
Given all that incredible capability, this is where it gets really interesting for us, right? What's our role in this future? What's left for humans to do?
The sources we looked at suggest a pretty clear partnership, actually. A division of labor based on what each does best. Humans need to own the domain of the why and the what.
Meaning, the big picture stuff, the goal.
Exactly. Setting the macro level objectives.
Yeah.
Determining the purpose, the meaning behind the work. Applying that wisdom and judgment we talked about.
So we decide what needs to be done and why it matters. Without that human direction, the AI's work is just efficient activity without purpose.
Precisely. High-speed meaninglessness. Our value is in setting the course, providing the ethical guardrails, applying the wisdom.
And that leaves the AI to handle.
The domain of the how. Once we humans clearly define the goal, the AI agents are incredibly good at figuring out the execution.
Breaking down the big goal into all the little steps.
Thousands of micro goals, yes. Automating the tasks, managing the resources, optimizing the process. Doing it all far faster and often more reliably than a person ever could.
So they handle the mechanics, the complex execution.
While we handled the meaning, the purpose, the ultimate direction, it's a partnership.
Okay, so wrapping this up, we've seen AI crush historical limits. We see the current frontiers, AGI, sustainability, true wisdom are still being worked on. But the direction, the trajectory, seems pretty clear.
Undeniably towards greater capability. And maybe the biggest takeaway from this whole deep dive is that history really warns us against getting too hung up on today's limitations.
Because claiming to know what AI will never do.
It's usually the fastest way to look foolish in a few years. Don't bet against AI's potential. The future will involve AI doing things we probably can't even conceive of right now.
Which brings us back to you, listening. This field is moving so incredibly fast, the conversation is always evolving. We talked about wisdom and common sense as maybe the hardest nuts to crack right now. What stands out to you? What do you think is the next impossible barrier that AI is going to break through?
We'd genuinely love to hear your thoughts on this. Please share your ideas and suggestions down in the comments section below. Your insights really do add to the conversation.
Absolutely. And if you found this deep dive helpful or interesting, we'd really appreciate it if you let us know. Please give the content a like, subscribe to the channel if you haven't already, and definitely hit that notification bell.
That way you won't miss out on any of our future discussions. And please share this deep dive with anyone else you think might find this analysis useful.